Hello friends. So today we are going to study about periodic functions and Fourier series. In this lecture we are going to study about the different type of periodic functions and its conversion in Fourier series form. We will be also studying about its application in frequency and time domain series. So to start with, let us understand what is a periodic function. So any function f theta will be periodic if the value of f theta repeats after certain value as t. So if f theta plus t is equal to f theta, then this function is called as periodic function. For example, let us take this function and see the f theta value. So the function f theta is repeating its value after every t. That means if at theta 1 the value of function is this, at theta 1 plus t also the value of the function is same. So it is having a periodicity t, and this function is periodic. Similarly, we can take this square wave example. In this we can see that this function repeats after every t. So this is time period of the function. Some more examples are this triangular wave, and the time period is the time duration between these 2 points, or time duration between these 2 points. So what is Fourier series? Fourier series is the trigonometrical representation of any given function f theta in terms of a cos function, a sine function, and one constant. We can calculate the individual constant a0, an, and bn involved with the Fourier series. Let us assume that a function is having periodicity 2 pi. So there are three components in the Fourier series. The first one is a0, second one is an cos n theta, n starts from 1 to infinity. Then bn sin theta, summation of bn sin theta, n starts from 1 to infinity. So this is function is basically cos theta, cos 2 theta, cos 3 theta, and so on. And this is sin theta plus sin 2 theta, sin 3 theta, and so on. We can understand separately how cos theta, cos 2 theta, cos 3 theta, etc. looks like. So let us take angle from 0 to 2 pi, or theta from 0 to 2 pi. Then the red color is cos theta, then blue color is cos 2 theta. So we will have two dip, one is here, another one is here for cos 2 theta. Similarly, for cos 3 theta we have three lowest point, and so on. If we increase like cos 4 theta, cos 5 theta, and so on, the number of lowest point will keep on increasing, but the initial value is 1 and final value is again 1. Similarly, if we take sin theta or sin 2 theta or sin 3 theta and so on, the initial value at theta equal to 0, it is 0, and the final value is also 0. So by counting the number of highest point or number of lowest point, we can find this is sin theta, sin 2 theta, or sin 3 theta, and so on. So if there are only one highest point, then it is sine theta. If there are two highest point, then it is sine 2 theta. If there are three highest point, then it is sine 3 theta. Now, to determine the coefficient an and bn, which is there in the Fourier series, we have to first remember some of the useful integrations. So the first integration is minus pi to pi cos n theta d theta. So the multiplication of two cos function, we can expand this in terms of summation as cos n plus m theta d theta and cos n minus m theta d theta. As we know that for any positive value of n plus m here, this total integration will become 0. Let's say it is a cos theta d theta, then the integration will be sine theta. And since this is integrated from minus pi to pi, so sine pi will be 0 and sine minus pi will be also 0. So the integration will be 0. So for any value of n and m, this function is always gives 0. Similarly, this function will also give 0 for any value of n and m if the n minus m is a positive or negative number. So if n and m both are unequal, this is going to be n minus m is going to be non-zero and n plus m is also going to be non-zero. And for any value of non-zero cos theta d theta, the complete integration will be 0. So the integration of this function will be 0 if n and m both are unequal. And if n and m both are equal, in that case, this integration is going to be 0, but this integration will have some value because n minus m leads to 0 since n equal to m. So cos 0 is 1 and this will give theta, which is integrated from minus pi to pi. So it will become pi. The second value will be pi. So if m and n is equal, this integration will give us pi. Now next important integration in this Fourier series is sin n theta into cos m theta d theta for a period of minus pi to pi. So if both are different function, one is sine, another one is cos, we can expand this as summation of two sine function. One is sine n plus m theta, another one is sine n minus m theta. And we know that any sine function will have the integration 0. So this will also give 0 integration and this will also give 0 value. So overall value will be always 0 for any value of n and m, including n equals m. If n is equal to m, it will become sine 0. So this value is 0. For all other value, this will give a cos function which is same at pi and minus pi. So the difference of these two is going to be 0. So for any value of n and m, this function gives you always 0. The multiplication of sine and cos theta will always give 0. Now the next function is sine n theta into sine m theta. So if there are multiplication of two sine function, one is sine n theta, another is sine m theta. In that case, one function will be cos n minus m theta, another is cos n plus m theta. Again, the case is same as the previous one. The first one, the sine for different value of m and n, the integration is 0. For same value of n and m, integration is going to be pi. Now let us calculate for the coefficients. So the first coefficient involved in this is a naught, which is this one, a naught. To calculate this, integrate the function from minus pi to pi. We have already assumed the f theta function as a naught plus summation of an cosine theta and summation of bn sin n theta. Now we will integrate both the side from minus pi to pi. So if we integrate from minus pi to pi, this is a pure cos function. So the integration from minus pi to pi is going to be 0 for all value of n. Similarly, integration of a sine function will be 0 for all value of n. So in the left side we will have only this function minus pi to pi f theta d theta, and right side we have minus pi to pi a naught d theta. So this is minus pi to pi f theta d theta equal to minus pi to pi a naught d theta plus 0 plus 0. So this is how we can calculate this a naught coefficient. So a naught coefficient after calculation we will get 1 by 2 pi minus pi to pi f theta d theta. So we can say that a naught is the average value of the function, because this is the total value between minus pi to pi, and minus pi to pi we have total period is 2 pi, and we are dividing it by 2 pi. So this value is average of the function f theta. So it is also known as the DC value of the function f theta. We can also integrate this from 0 to 2 pi and get the same result. So if we integrate from 0 to 2 pi f theta d theta, we have to integrate from in both the side of the Fourier series, and cos function and sine function from 0 to 2 pi will be always 0. So we will have only 0 to 2 pi a naught d theta equal to 0 to pi f theta d theta, as we can see here, 0 to pi f theta d theta equal to 0 to pi a naught d theta. So a naught equal to 1 by 2 pi 0 to 2 pi f theta d theta. So it is true for either minus pi to pi or 0 to 2 pi. This will be always the average of the function for a period. Now to determine the an coefficient, we have to multiply by cos m theta on both the side of the integration. So here we have multiplied by cos m theta. So in these two coefficients also cos m theta will be multiplied. Now the first term is a naught into cos m theta. So it is a naught into cos m theta d theta, and we know that for any cos function integration from minus pi to pi will be 0. Then we have second term, which is an cos n theta cos m theta d theta, and we know the value of this. If n and m are different, the value will be 0. If n and m are same, then value will be pi. So we can write this summation as am into pi. And third term is minus pi to pi bn sin n theta cos m theta. So here sin and cos is multiplied together. So for any value of m and n, integration will be 0. We have only am pi in the right side. So the left side is minus pi to pi f theta cos m theta d theta. Cos m theta was multiplied, and right side we have got am pi. So am is equal to 1 by pi minus pi to pi f theta cos m theta d theta, where m is 1, 2, 3 and so on. Now to determine bn, we have to multiply both the side by sin m theta, and then we will integrate both the side from minus pi to pi. So if you multiply by sin m theta and integrate from minus pi to pi, we will get first term as a naught sin m theta. So this is first term a naught sin m theta d theta. This is a sine function, so integration is always 0. Then second term will be an cos n theta sin m theta d theta. So again cos and sine both are different function, and we know that integration will be always 0 for minus pi to pi or for 0 to 2 pi. So integration is 0 for this. The third term is bn sin n theta sin m theta d theta, which will be equal to bm pi, because for different value of n and m, the integration will be 0. So for the same value of n and m, we will have integration. So let us say for n equal to 1 and m equal to 1, we have integrated, so we will get b1 here. Similarly, if we take n equal to 2, this will become b2 pi, and then for n equal to 3, this is b3 pi. So in general, the integration is bm pi. So we can summarize these coefficients as a naught equal to 1 by 2 pi minus pi to pi f theta d theta, am 1 by pi minus pi to pi f theta cos m theta d theta, where m equal to 1, 2, 3, 4, etc., and bm equal to 1 by pi minus pi to pi f theta sin m theta d theta, m equal to 1, 2, 3, 4, so on. We can also write in place of m, we can write n and write this expression in terms of n. So there is no difference between the expressions. Now this integration can be performed for 0 to 2 pi instead of minus pi to 2 pi. So the a naught will be the same value. The integration will change from minus pi to pi to 0 to 2 pi. So all the integration can be done for the 0 to 2 pi, because 0 to 2 pi is a period. Now let us take the first example of Fourier series, in which a square wave is taken and the amplitude of the square waveform is a or minus a. So from 0 to pi the value is a, from pi to 2 pi it is minus a. Again from 2 pi to 3 pi it is a, and 3 pi to 4 pi it is minus a. So we can see that this value repeats after 2 pi period. Again after 2 pi the value is repeating. So the time period is 2 pi here, because function of theta plus 2 pi equal to function of theta, and this waveform can be summarized by f theta equal to a when theta is 0 to pi, and f theta is minus a when theta is from pi to 2 pi. Now to find the first coefficient of the Fourier series, we have to take 1 by 2 pi 0 to 2 pi f theta d theta, and this value we know from 0 to 2 pi there are two parts. One is 0 to pi, another one is pi to 2 pi. For 0 to pi the function is a, and for pi to 2 pi this function is value is minus a. So adding these two we will get 0. So there is no a naught coefficient in the Fourier series. So a naught equal to 0. Now to calculate an, we'll take the formula 1 by pi 0 to 2 pi function cos n theta d theta. And we know that for 0 to pi value is a, for pi to 2 pi the value is minus a. So when we calculate, again we will get value equal to 0, because this will give a positive value and this will give a negative value, and both are same, so the difference is 0. To calculate bn, we will multiply the function by sin n theta d theta and integrate from 0 to 2 pi and multiply with 1 by pi. Again we'll take the values. For 0 to pi, function is a. For pi to 2 pi, function is minus a. We'll integrate this separately and we will get minus cos n pi by taking the higher integration and cos 0 by taking the lower integration. Similarly, cos 2n pi by taking the higher integration and cos n pi by taking the lower integration. So there are four terms: minus cos n pi, cos 0, cos 2n pi and minus cos n pi. We can observe that this cos n pi is sensitive to the value of n. If n is even number, this value will be plus 1, and if n is odd number, the cos n pi value will be minus 1. So we have to write the value for odd and even separately. So let us assume the n is odd number. So if n is odd, cos n pi will be having minus 1 value. So this is minus and minus 1, so it's plus 1. Cos 0 is always plus 1, and if you take any odd number here, it is multiplied by 2, so it's even number. So this value is always plus 1 and this value is always plus 1. The first term and the last term is sensitive to odd or even value of n. So if n is odd, this will also give plus 1 and this will also give plus 1. So total value is 1 plus 1 plus 1 plus 1 equal to 4. So we will have Bn equal to 4a by n pi when n is odd. Now let us take the even value of n. If we take even value of n, this two value will remain 1 and 1, but cos n pi will be also 1 and this is also 1. So with a negative sign, this will become minus 1 and this will become minus 1. So total value of this 4 term going to be 0. So the Bn is 0 when n is even. Bn is 4a by n pi when n is odd. Let us say n is odd and the first odd number is 1. So Bn value will be 4a by pi. If we take n as 3, Bn will be 4a by 3 pi. If n is 5, it is 4a by 5 pi and so on. If n is 2, the Bn value will be 0. So we can write this as a Fourier series. The 4a by pi will be common and we have already seen a naught and an both were 0. So this can be written as 4a by pi sine theta plus 4a by pi sine theta by 3, then sine 5 theta by 5, sine 7 theta by 7 and so on. So what we can see is the number n is increasing up to infinity. So when we write in Fourier series, we will not be able to write all the numbers here. So let us assume some few terms of this infinite series and then see how it affects the original square wave. So let us consider the four terms. If we take four terms here, that means the first, second, third and fourth. These four terms, then we will get function like this. If we increase the number of terms, the number here will increase, because we know that for sine theta, for the value 1, we have only one peak or only one lowest point. If it is sine 3 theta, there will be 3 peak and 3 lowest point, and so on. So this is the uh, graph when we consider 4 terms in the Fourier series. Here the 6 terms are considered, and we can see there will be 6 number of ripples here. Similarly, this one is considered with the 8 terms and there are 8 ripples. This is for the 12 terms and the number of ripples increased, and also this line, this vertical line is getting aligned towards the y-axis. So this is comparison between 4 terms and 12 terms. What we can observe is the ripple width is decreasing with the number of terms increasing. Also, the line is aligned towards the y-axis. The blue color is with the 4 terms, which is inclined or which is away from the y-axis, and when number of terms are increasing, it is approaching parallel to the y-axis. This is the close-up of this comparison of 12 terms and 4 terms, and we can see the difference. This is with the 12 terms which is aligning towards y-axis, and the 4 terms is little bit away from the y-axis. Similarly, if we increase the number of terms to 20, this is going away from the 4 terms line and approaching towards the y-axis, and also the width of this ripple is decreasing and it's very less. So if it tends to infinity, it will become a straight line here, and it will be equivalent to the square wave what we have considered. So in next video we will be studying about the even and odd functions and how to write Fourier series for even and odd functions. Thank you.